Wow, the NASA hotline is ringing off the hook. The call center operator is all sweaty from stress. They barely have time to answer the phone, and all the messages they get say the same thing. There's something glowing on the moon. Indeed, hundreds and thousands of amateur astronomers were watching the moon that night. And suddenly, there was a bright light on it, as if someone had lit a powerful spotlight on the surface. Scientists immediately began to look for an explanation to this phenomenon. They first thought it was simply the glow of an airplane flying between the observers and the moon. But then it wouldn't have been seen by so many people from different parts of the world at the same time. The next suspects were the Starlink satellites. Theoretically, one of them could have played a cruel trick on amateur astronomers. They could have mistaken the small satellite's light for a flash of light on the moon. But then again, if the satellite were the culprit of this mess, the flare wouldn't be static, but moving. While some scientists continue to search for an answer to this mystery, others decide to investigate the phenomenon in more detail. For this purpose, they have built a new telescope north of Seville, Spain. The conditions there are quite suitable for observing the moon. The telescope has 2 cameras, controlled remotely from the campus in Germany. If both cameras pick up any unusual phenomenon on the surface of the moon, it will quickly zoom the telescope there to see what's going on. It'll also require advanced artificial intelligence to teach the cameras to distinguish between the unexplained phenomenon on the moon and the light of an airplane, a satellite, or a small meteorite that just entered the Earth's atmosphere. While the telescope is doing its investigation, we already have a theory that may explain the appearance of such bright round flashes on the moon's surface. So, the moon influences the tides of the seas and oceans on Earth with its gravitational force. But the Earth can affect the moon in the same way. Only the force will be 32.5 times stronger. While the moon orbits the Earth, at one point it may be as close to our planet as possible. Then the force of the interaction will be greatest. At this point, tidal forces may force cracks in the surface of the moon to open and release gas from its interior. A powerful jet of gas will lift the lunar dust with it, and what we see as a bright flash through our telescopes is really just a fog of dust, which is round and reflects sunlight well. If you look at it from a distance, it really does look like a flash. As the dust rises, we think there's been a small explosion, and that flash gradually fades as the dust settles down. These things happen all the time on the moon's surface. They're called transient lunar phenomena, and besides lunar flashes, much more mystical and bizarre things have happened. Back in 1178, 5 monks claimed to have seen the moon, being in the shape of a horn, begin to split in 2 from an upper point. Then fire and sparks began to blaze from the place of separation. It was as if a dragon were spewing flames. In the next moment, the moon began to pulsate and then returned to its calm state. This phenomenon was repeated more than 10 times, and the flames took different shapes each time. When this nightmare was over, the moon turned black. It wasn't until the 20th century that scientists tried to explain the phenomenon. They theorized that a large asteroid collided with the moon at the time, and it was this asteroid that should be blamed for creating the Giordano Bruno crater, 15 Brooklyn bridges wide. But in that case, millions of tons of fragments from the asteroid would have hit the Earth as well, and then people would have seen an incredible meteor shower. It would have been very bright, and the memories of it would definitely have been in the archives. But that didn't happen. Now the phenomenon the monks observed seems questionable. Perhaps they did see an asteroid fall, only it was falling on the Earth itself, and they perceived the light from the burning meteorite as something sinister happening on the moon. Or maybe the monks were simply imagining things. There's no witnesses to this event other than them. Another unusual phenomenon is the blue and red lights on the moon. They can be seen when it's horn-shaped, and this occurs most often in the Aristarchus crater. The flashes come and go very quickly, almost like lightning. In fact, this is electricity. Tidal forces are to blame for this too. They cause mechanical stress to build up in the rocks. This can produce an electric field, which creates the blue flashes that have surprised many amateur astronomers. There can also be starbursts on the moon. We can blame this on meteorites that fall on the surface. Because the moon has no atmosphere, asteroids that approach it don't burn up. Having a lot of weight and speed, they cause an explosion on impact. And here on Earth, we see it as a starburst. For example, on May 13, 1972, there was a meteorite impact of 1,000 tons of TNT near where Apollo 14 landed. If we lived much earlier, we might have witnessed constant bright flashes on the moon's surface. All the craters there are formed by such meteor strikes. So imagine the fireworks that were there years ago. And a lot of those meteorites were even useful too. They brought water with them. Yes, there is water on the moon. NASA confirmed this fact after studies with the SOFIA telescope. It was mounted on an airplane. The observations were made from the upper atmosphere of the Earth. At such an altitude, the dry air allowed the telescope to see even the smallest details. Water might have been in the craters at the poles of the moon. These places have never seen light, and the water there might be encased in ice. But SOFIA found water on the sunlit surface of the moon. Of course, it's only H2O molecules that are present in the dust layers, but that's something. If we manage to collect all this water, we'll get very little of it. In comparison, the Sahara Desert has about 100 times more water than we found on the moon. But an even more unusual phenomenon is happening there right now. The moon is actually rusting, just like a piece of old metal. For rust to appear, we need iron, water, and oxygen. Lunar soil has enough iron in it, and as we've already learned, there's some water too. The last piece of the puzzle is oxygen. Everyone knows there's no atmosphere on the moon, and we can't breathe there, but oxygen is still present. The solar wind brought it there. The wind from our warm star moves at an extremely high speed. It scrapes oxygen from the upper parts of our atmosphere and carries it further through space. Eventually, the wind with the oxygen molecules reaches the moon. Voila! All the ingredients for corrosion are in place, and the iron ore on the surface of the moon begins to take on a reddish hue. If this process goes on long enough, in the distant future, the moon will look like Mars. It will turn orange-red. Yes, the signature color of Mars came exactly from that corrosion that began there thousands and thousands of years ago, when there were rivers and seas with water and an atmosphere with oxygen. Other strange objects that can be seen on the moon were left there by humans. Between 1969 and 1972, 12 people visited there as part of the Apollo program. In all, there were 6 landing sites where the astronauts left a bunch of stuff behind. Besides a couple of dozen satellites and spacecraft that fell or landed softly on the moon, there's a lunar rover, some United States flags, a family photo of one of the astronauts, and even 3 golf balls. And the first 2 people to be on the moon left behind a whole pile of stuff. When they were about to go home, they took a lot of soil samples and rocks with them. And to carry it all away, they had to get rid of everything unnecessary on board the lunar module. The TV camera, the sample collection tools, the science equipment, and even the armrests from the seats. The astronauts stood outside the lunar module for a full 8 minutes and threw out a whole mountain of unnecessary items. If you collect all these objects and debris that we left there by 12 astronauts and put them on the scales, it will show about 199 tons. It's like 3 heavy armored tanks or 3 large passenger planes. Strange, but true.
The Moon. A beautiful, natural satellite with some mysterious dark splotches. We always see only one side of it, so we're used to this image. It's hard to imagine the Moon looking any other way. But it used to be different. Oh ho ho, it used to be so different. Picture this, a huge incandescent satellite in the sky that is causing constant tsunamis. I suggest we go very far into the past to see what the Moon was like many, many years ago. The Moon formed around 4.5 billion years ago. At that time, our green-blue planet was still a red-hot, insanely unstable piece of rock flying in space. We didn't have the Moon yet, and a day on our planet only lasted 6 hours, which meant only 3 hours of daylight. Volcanoes erupted all over the place, releasing poisonous gas into the air, and a bunch of meteorites regularly crashed into the planet. At the same time, 4.5 billion years ago, the so-called Big Splash occurred, or, as scientists call it, the Giant Impact Hypothesis. It claims that once an object the size of Mars crashed into Earth. Mars is about 2 times as small as our planet, so the blow wasn't too bad, but it was quite catastrophic. This powerful impact tore off part of the outer layers of that Mars-sized object and Earth. The very core of this space body merged with Earth's own dense core, and a huge number of fragments of Earth flew into outer space. So, this was the beginning of our Moon, or, saying in a scientific way, the process of differentiation has begun. This is the process all planetary bodies go through at the beginning of their lives. Since the impact was very hot, its heat carried away most of the gases and liquids from the broken pieces of Earth. Only a relatively dry stone surface remained. So yeah, there is water and gases on the Moon, but in very small quantities. The gravity of our planet was strong enough to make all these hot stone fragments stay in its orbit, and they gradually began to stick together. The chemicals they contained were distributed in layers. Iron, which was heavier, sank deeper inside, and lighter elements formed the surface. In a short time, 100 years or less, the ring of steam, dust, and molten rock fused together. The largest clusters with the strongest gravity attracted more and more particles, gradually forming the Moon. It looked like a red-hot bubble ball. Sadly, the nucleus of this newborn Moon turned out to be very small. It lacked iron and other heavy elements to form into something substantial, like a planet. The oldest rocks of the Moon probably formed in the ocean of magma. And when the Moon gradually cooled down, it turned out to be a white, clean, and perfectly even ball. But it was still completely different from what we have now. To begin with, immediately after its birth, the satellite was located at a distance of only 13,500 miles away from Earth. This is 15 times closer than it is now, around 238,000 miles. It's scary to imagine how huge and bright the Moon looked in the sky at that moment. The view was probably both beautiful and terrifying. And, of course, such proximity caused incredibly huge waves on Earth. The planet experienced regular tsunamis. Also, at that time, the Moon was spinning very fast, and it wasn't turned to Earth with only one side. But, in general, Earth and the Moon had a positive impact on each other. For example, it was the Moon that made our day last 24 hours. Now, Earth's axis is mostly tilted 23.5 degrees from the plane of its orbit around the Sun. Without the Moon, Earth rotated rapidly, but thanks to the satellite, the planet's tilt stabilized, which led to a wide and pleasant variety of climates on Earth. To be fair, the gravity of our planet also helped the Moon. Thanks to it, the Moon began to rotate more and more slowly while gradually moving away from us. Over the years, its orbit has moved far away from our planet. At the same time, the Moon became tidally locked to Earth. This means that its rotation period coincides with its orbital period. Or, in other words, the Moon moves around itself as fast as it moves around the Earth. That's why the Moon always faces our planet with only one side. When the Moon moved away, tides on Earth became calmer. Now, water could flow to the most remote corners of our planet. It was then that life appeared on Earth. But back to the evolution of the Moon itself. What was happening on its surface after its formation? The next stages of the Moon's development were childhood and adolescence. And as is usually the case at this stage, this period was insane. No wonder. About 4 billion years ago, the solar system was going crazy. During the first 600 million years of the Moon's existence, large asteroids and comets constantly collided with it. Now, they were bothering not only our Earth, but also its satellite. These impacts were the most powerful in the history of the Moon. They left many large craters, which were later filled with dark rock. So, Earth wasn't enough for you, huh, space? Once, a dwarf planet crashed into the Moon. It was about the size of Ceres, the largest object in the asteroid belt between Mars and Jupiter. This explosion formed the SPA basin and also forever changed the appearance of the Moon. Can you see that dark spot on the far side of the Moon? Right there in this very south? This spot is called the South Pole Aitken Basin. Its diameter is about 1,600 miles. And yes, it was formed by the impact I've mentioned, about 4.3 billion years ago. This planet brought with it a bunch of complex and strange chemical compounds that scientists are now finding all over the far surface of the Moon. These compounds began to emit a lot of heat, melted part of the lunar mantle, and, oops, accidentally woke up volcanoes. The volcanoes began to erupt furiously. A huge amount of magma was distributed over the surface of the Moon. Many years later, it cooled down, leaving behind those famous dark splotches that we're so used to. They're called the lunar maria. There are much fewer craters there than on the lunar highlands. But for the last billion years, the Moon has been geologically inactive, except for occasional collisions with meteorites. In general, the appearance of the Moon changed forever as a result of these events, and, battered and tired, it entered adulthood. But even then, it couldn't get any peace. A bunch of meteorites decided to bother it again. Honestly, it wasn't that bad. There were many collisions, but all of them were quite small. They just left a bunch of craters and pits on the Moon and maybe damaged its mantle a little. Some of the collisions deepened already existing large craters. The Moon's crust was getting thinner and thinner over the years because of all the chaos going on. And now we call this upper part of the lunar crust covered with craters the lunar highlands. All those white and bright areas of the Moon, the highlands. But in the end, the universe finally calmed down, for now at least, and the Moon began to look the way it does today. There are still many things we don't know about Earth's natural satellite. There are moments in its history that scientists still can't accurately explain, but they're continuing to study our beautiful satellite. The data about the Moon is useful to people not only for its own sake. It gives us a more complete picture of both the history of our solar system and space as a whole. So, let's hope that one day we'll be able to find out everything there is to know about the Moon.
That's it for today. So hey, if you pacified your curiosity, then give the video a like and share it with your friends. Or if you want more, just click on these videos and stay on the bright side. Imagine stepping out of your spacecraft and setting foot on the surface of the Moon. Under your feet, the ground is covered with a fine material that looks like powder. That's lunar dust. You look around and take a lungful of fresh air. It smells very different from the air on Earth, but still nice. Now, unfortunately, this is a highly unlikely scenario, and one of the reasons is that the Moon has almost no atmosphere. Earth's natural satellite is too small, less than 2% of our planet's mass. That's why it doesn't have a magnetic field strong enough to keep an atmosphere. But even if the Moon had it, solar winds would immediately pull it away. But if you could visit the Moon 3 or 4 billion years ago, you'd see a very different picture. At that time, the Moon most likely had an atmosphere. It formed at the times when powerful volcanic eruptions were rocking the satellite. Gases spread all over the Moon's surface. It happened so fast that they didn't have enough time to escape into space. At that time, the lunar surface was covered with basins filled with volcanic basalt. Just imagine ginormous plumes of magma hurling high into the air, falling to the ground, forming lava flows. That's how the basalt basins appeared on the surface of the Moon. At one point, scientists on Earth got their hands on samples brought from the Moon. They found out that lava flows there contained not only carbon monoxide and sulfur, but also the building blocks of water. Thanks to these samples, researchers managed to calculate the amount of gas that rose and formed the atmosphere. It became the thickest around 3.5 billion years ago and existed for about 70 million years. After that, poof, the atmosphere was lost in space. But the coolest thing? When the moon did have an atmosphere, the satellite was 3 to 10 times closer to our planet. One computer simulation even suggested the moon was probably up to 19 times closer than it is now. The distance between it and our planet could be 18,600 miles, while these days it's around 240,000 miles. That's why the moon looked much bigger in the sky. Unfortunately, at that time, not even dinos were around to admire the view. Neither was I. At the same time, the most recent studies have confirmed that our moon actually does have an atmosphere. It's composed mostly of hydrogen, neon, and argon, and contains some very unusual gases, like potassium and sodium. You can't find them in, let's say, the atmospheres of Mars, Venus, or Earth. Sadly, such an atmosphere isn't suitable for us oxygen-dependent creatures. But guess what? There's loads of oxygen on the moon. I know, it must sound confusing, but the thing is, this oxygen isn't in its most common gaseous form. It's trapped in a layer of rock and dust covering the surface of the moon. This layer is called the regolith, and it contains up to 45% oxygen. So, does it mean that if people learned how to extract this oxygen, we would be able to live on the moon? Not so fast. The oxygen in those rocks is very tightly bound into the minerals, and to break these components apart, we'd need tons of energy and special equipment. But if people managed to start this process, the moon would deliver quite a lot of oxygen. Now, there's a theory that the moon might have been formed during a collision between Earth and another planet. This planet must have been smaller, the size of Mars. It probably happened around 4.5 billion years ago. Another theory claims that the moon used to be an asteroid or some other wandering body. It formed somewhere else in the solar system. When it was passing by Earth, it got caught by our planet's gravity. Other experts think that at some point in the past, Earth was spinning so fast that some of its material broke away. It soon started to orbit our planet, and that's how the moon appeared in the sky. And the least exciting theory claims that Earth's natural satellite could simply appear along with Earth during our planet's formation. These days, the moon is the 5th largest natural satellite in our solar system. It's also one of the densest, second only to Jupiter's satellite Io. Most likely, the moon has a tiny core, no bigger than 2% of the satellite's mass. About 420 miles wide, it consists mostly of iron and sulfur. The moon's surface is dark, even though Earth's natural satellite is the brightest object in the night sky. But in reality, its reflectance is just a bit higher than that of asphalt. You might have heard that the moon, along with the sun, causes tides in the oceans and seas on Earth. The satellite's gravitational pull creates something called the tidal force. It makes the water bulge out on the sides that are the closest to the moon and farthest from the satellite. These bulges are what we know as high tides. But what not so many people know is that the moon also causes rocks to rise and fall, just like it does with water. Of course, this effect doesn't look as dramatic as ocean tides, but it's still noticeable. Earth's solid surface moves by an inch or so with each tide. Now, not only does the moon cause tides on our planet, but it also slows down its rotation. This phenomenon is known as tidal breaking. It increases the length of a day on Earth by a bit more than 2 milliseconds per 100 years. The moon is also moving away from Earth at the same rate at which your fingernails grow. That's about 1.5 inches per year. You should really cut those. If one day it floats away into space, our planet will have to live through tough times. Without the stabilizing pull of the moon's gravity, Earth's tilt would start changing wildly, from no tilt at all, meaning no seasons, to a large tilt, resulting in extreme weather. Since the moon doesn't have an atmosphere, nothing protects it from extreme temperatures. It gets incredibly cold on the night side, minus 390 degrees Fahrenheit. Meanwhile, the sunny side is literally boiling, with a temperature of 250 degrees Fahrenheit. Another thing the moon can't protect itself from without an atmosphere is meteorites. That's why the surface of the satellite is dotted with craters. For comparison, there are about 190 identified impact craters on our planet. Many of them are hidden by vegetation or covered with water. But if we speak about the moon, the number is so much greater, several million, and around 5,000 of them are more than 12 miles across. The moon is less seismically active than Earth. That's why these craters and other ancient formations stay in perfect condition for centuries. But even though the moon's surface is mostly dormant, Earth's natural satellite still experiences moonquakes. They start several miles beneath the surface. One theory suggests that they may be happening because the moon is shrinking as its insides are cooling. Scientists say the moon has become around 150 feet skinnier than it used to be several 100 million years ago. So, how does it work? Well, picture a grape turning into a raisin. It wrinkles while shrinking. The same is happening to the moon. It's shrinking and it's wrinkling. But unlike a grape, the moon doesn't have any flexible skin. Its surface is hard and brittle. So as the moon gets smaller, the crust cracks and breaks. Its sections get pushed over neighboring parts. Researchers are sure that such faults are still active and likely responsible for the quakes shaking the moon. Some of these quakes are pretty strong, up to 5 on the Richter scale. When you look up at the moon, you always see the same side of Earth's natural satellite. Like our planet, the moon rotates around its axis, but this rotation lasts around 27 days. This is the same time the moon needs to orbit Earth. Such a phenomenon is called tidal locking. Before space exploration started, people had never seen the other face of the moon. They didn't know what the far side looked like. While the near side of the moon is mostly large plains covering impact basins, the far side is rugged and cratered. The crust is thicker there, with less evidence of volcanic activity. Oh, by the way, the moon isn't perfectly round or spherical. It's shaped like an egg. When you're looking at it, one of its small ends is always pointing at you. Yep, right at you. This is the reason why the moon's center of mass isn't its geometrical center. In reality, it's a bit more than 1 mile off-center, like a poorly made golf ball.